That's not a parallelogram.
There it is.
It's an octagon. It's got 8 sides.
Yeah.
It's a parallelogram as well.
And look.
Because all the lines are parallel.
That's not a parallelogram. It goes on how many sides there is to a shape, not what they look like.
It's got, like, parallel lines in it.
Misconceptions are those reasoned ways of thinking that are different from the ways that other people in the maths community generally agree we should think.
I believe a parallelogram, you have all of them are parallel, but 2 are longer than the other. Well, that's why that isn't a parallelogram.
That's why it's a rhombus.
A rhombus has equal sides and all of them are parallel. I believe. I mean, that's what I'm getting from looking at these.
Rhombus, yeah.
So, that's definitely an octagon.
Not all mistakes are due to misconceptions. People make mistakes because they are just being careless for a moment, or maybe just rushed something.
So, what tells you that that equation is a straight line then?
Well, it's just the fact that it doesn't have an x squared and it'll be straight. So anything like your minus or positive tells you which direction it'll be in as well.
OK, so if it hasn't got an x squared in, it's a straight line. And you know what shape graph that is?
No. So one seems to be winning it every time.
Something wrong with the program. Is that what it's meant to be?
We don't find that misconceptions are generally removed or put right by more careful explanations. There's no kind of magic pill for them.
When you have 2 coins, there are 3 possible outcomes: 2 heads, 1 head, or no heads. So the probability of 2 heads is, it says they're 1/3, but I think it should be 2/3.
Do you know the one we done at the time you came up
no,
with?
No, it is 1/3. I think it has to be one of them, isn't it?
Yeah.
We've had some teachers who've worried that if they discuss misconceptions, then some learners who haven't got these misconceptions might start believing in them.
So if we've got 0.5 squared is 0.25, is 0.25 greater than 0.5?
You have to really look at the thinking that's behind them and work on that. And the way I tend to do that is through finding something that will cause some conflict.
Why if you square up half numbers, it can go down instead of going up?
And this conflict causes them to examine what they believe and adjust it to accommodate this new idea.
If 2 times 2, yeah, is 4, yeah?
It gets bigger.
You're timesing 2 by 2, yeah?
Yeah?
So wouldn't it be like 0.5 times 0.5 is 1.0?
As we go on in maths, we develop and change in our views of mathematical ideas, and we develop our understanding in different ways and broaden our definitions as we go on.
If you times that to get off the bottom, would it actually just go to that side? Or because it's a 0, would it just disappear?
That's what I thought.
Well, write it down then. You're thinking, well, it's good stuff. You're thinking, I love it.
I thought that was wrong because it disappeared.
I thought we were trying to fancy, but that would make nothing.
Yeah.
Misconceptions are about the way people think, and that's what maths teaching is all about.
So what does that tell you about a stationary point?
They're in one.
Yeah, precisely. Well done.